Welcome everybody to this somewhat misleading title on building full stack apps on nil. If I were to read this, I think I would imagine the front end would be hosted on chain too, but that's not really the case here. This will be just your back end on chain on this case. Yeah, so for those who don't know, I think most of us know, Nil's coming up with a new layer 2 for Ethereum. We're going to launch it towards the end of the year this year. We're in testnet right now. There's an RPC bot that can dispense RPC URLs for those who want to try it out. So by all means, do check that out. The links are in our main site. What we'll cover today, understanding what ZK sharding means. This is the main idea behind Nil's coming L2. Bootstrapping your first DApp. Our Uniswap v2 on Nil implementation. That's quite cool to cover on a higher level and walk through the repo, and then some questions towards the end. But if you got questions throughout the presentation, just don't be afraid to just interrupt me. I think it's better to keep it iterative. Yeah, ZK sharding, what does this mean? You can see it like, first I like to look at it sharding first. That's partitioning state by account on an account level. So if you get like all your EVM state and just split it by 4, and each shard has like this quarter of the EVM state, then each quarter has its own subnetwork, and it all acts independently and performs async calls between each other. So in fact, the messages here pass between shard 1, 2, 3. There's 4 shards in testnet. Those are async. And the ZK portion is for generating ZK proofs for state transitions for each shard. And these are all aggregated on a main shard level. The main shard acts from a coordinating point of view and from a proof aggregation point of view, but it doesn't like perform any transaction execution like the other shards would. Yeah, that's the higher level of how it works. The developer is responsible to choose where to deploy contracts for each shard and take into account like how they think their app will behave in mainnet or in testnet once people are using it. So you have to take into account like what shards people's accounts belong to. They're going to interact with your app, or if you want to make a distinction that people should have like an account on some given shard to interact with your app. But yeah, we'll see that in the example in a bit. This is on a high level how it works. So yeah, bootstrapping your first DApp. Yeah, let's run through the example. So I have this repo I called nil template. I can share it later. It's in my GitHub account. What it does is there's an NFT contract. So we go here. It's not a standard OpenZeppelin NFT contract. It's one I define myself. And it doesn't have all the standard methods in there, but it does have like most of them in there. So, or a fair share. Balance of, owner of, token URI. I made some aggregation for the token IDs. Yeah, string conversion function, and the minting function. It's nothing really very special, but I made some scripts here that deploy this contract to all 4 shards. And I also have a front end that can view the NFTs for any given account that has these minted tokens to it. So let's run through it. So what I'm showing here is our JavaScript dependency. So it's based off the syntax at the moment. It's based off what we see in ethers. But actually, I'd like to invite a lot of feedback on what you see here and whether you like it or not, or how you'd like to see it differently. Because it very much is in initial stages, and I think it could use some refinement. But the deployment flow looks like this. For testnet, we have in our network in testnet, there's like a built-in faucet, so you can call this like top-up function. And the faucet URL, the RPC has a faucet URL as well, a faucet endpoint. So yeah, we call a generate smart account function here, then call a top-up with a wallet. Because something else to note, there are no EOAs on nil, so everything's a smart contract. So you could say there's like built-in account abstraction. So there's like native account abstraction. So so everything's a contract here. So every account has some logic to it. So you have to see if like the contract's deployed to it or no, to an address. So that explains this part here, deploying a wallet. That's what that means. And for each shards we do the same, right? We grab the sol.c binary for that contract and just deploy it to the shard. So here, that's where we do that here. And then we wait to see if, like, from the receipt, if things went well. So I think running this is straightforward. We can try doing it now. Typing with one hand is slow, but bear with me. If the network's online, this should work. Scripts. And deploy. There. Beep. Topping up wallet. Okay, it's doing stuff. That's great. Yeah, so the network's online, and I can do my demo, which is awesome. So now we have, for the first binary deployment on the first shard, an address, and now we're going to get it for the second shard. Great. Third shard coming up, then fourth shard in a bit. So I think it's important to note that nil is EVM compatible, but not EVM equivalent. And what does that mean for some who maybe not know is the RPC methods are not like one-to-one identical. There are either some extra ones with different names, or like the signatures in some, and the parameters are different. So something to bear in mind. It's covered in the docs, so you can just see the translations in the docs. It's easy. There. So now we know the 4 addresses that where these contracts were deployed to. So let's just do something very manual here, and let's go to this mint script. This is this script where these NFTs can be minted. So we just grab the first shard NFT contract address. I'll paste it in here, and a recipient address. Let's actually make a new one. Let's see if I can open a new tab. Yeah, that's nice. Sandbox. So you get to see some extra stuff here during this demo. Playground. Boop, boop, boop. Block Explorer. So that was our docs. This is our Block Explorer. And this is our playground. This is our web IDE. Why am I here now? Because I want to create a new account address with my RPC URL. So let's go to my .env and share with the universe my private key and the rest of YouTube. So let's do that and put that here. So, and I seriously hope to see my testnet account in a few months being drained. And if I'm not, I'm disappointed at everyone here. So yeah, so this will, you can get a URL like this from the bot, and this is what I wanted, a new account, so I got it here. There are neater ways to do this, but I also wanted to show, So, okay, we go back, we have our address, our recipient address, let's just paste it in there. Okay, let's run through the script. What it does, again, Node.js, and it gets the ABI from the build. And we construct a client very much like Ethers. Again, we generate a smart account for the transaction. In this case, we make no distinction. Yeah, this is just some random other account that can perform the mint, because in the NFT contract, there's like no only owner modifier or anything. Anyone can perform a mint. So again, we check a deployment status. We deploy that random account, and then we construct the contract, just like in Ethers you would. well, not entirely the same, but yes, very similarly. And then we call the mint function of the deployed NFT contract. We give it our recipient address and a token URI. In this case, let's just give it like some meme image with some something fun. I think this is the one and only, actually. There we go, copy link address. This might be a very ugly string, but it should be able to do that. Oh, well, that's very simple. Do that, so back to the function. Yeah, you give that token URI, receipts, very similar to like the deployment. We just want to make sure it ran well. Yeah, and then done. So let's run it. Mint. I think what takes a while here is the topping up. Yes, that takes a bit. And deploying the wallet the first time it's created. So that generate smart account function, it takes a while to run because of the deployment part after it. So now it's printing the script because I think I forgot to remove that console log somewhere. Yeah, receipt. So that's why I did that. But if I scroll upward, transaction confirmed. Great. Okay. So we even have a mint transaction hash. So that went well. Cool. So the NFT is minted. Would be nice to see it on some front end. So that's what I made here. So this is the JX portion. HTML portion is like super simple. You'll see it live, but it's just like you enter the address and then it'll show you the NFTs. And it also uses Node.js here to fetch them. So in this case, you give it the address of the contracts for all 4 shards where the NFT contract lives. And depending on the address you give it, because every address on nil has the shard number in the first 4 characters, as you can see. So it's very easy to know like in what realm it belongs to. And then you can just follow this mapping to do that. So because I don't want to copy paste all these values, I'll just do the one for the first shard. And let's see, where does my account actually live at? That might be important. Also on the first shard, great. Okay, so let's just update this one. And yeah, I'll need to update this one to what's in the .env. There. And yeah, we have the get shard ID from address, helper, create client, load NFTs. Yeah, it's very similar to the script flows that we've seen before. And it just calls a different method on the deployed contract, depending on what shard it belongs to. And then it shows the NFTs as cards. So let's just actually see it live. npm run dev. Let's do that. Okay, 5713. Okay, what was the address again? Here. Beep. Paste it in there. Loading your NFTs. No NFTs minted yet. Oh, that's sad. Well, let's try to do it again. Let's see if this works. Copy image address. We have a transaction hash. Mint successful. Yay. Okay. Let's look at the logs. Actually, I'm quite curious. Did it say anything here? Yeah, it seems as if everything went just like with the scripts. but I must have pasted in an address wrong at some point. But yeah, that concludes, I think, how this works. I wanted to show how Node.js worked, how interacting with the testnet worked, a simple example of how it works. And I think we were able to see how we can use different shards. But there's obviously, you can go a step further and make it a little bit more advanced. But that's a little too much to cover in this short session. So instead, I'll just point you guys to our monorepo for now. We have this Uniswap v2 implementation. And what it does, and I'm hoping there's like a diagram in here, but there was this very nice diagram, which I should have included in my slides, but I haven't. Uniswap v2 on nil, what happens is that the pair contracts are deployed on different shards every time. So say there were like a lot of trading activity on one pair, at least that one shard would be limited to that over congestion, and the other pairs would still be able to trade. I think this is interesting when thinking about like arbitrage between shards, because cross-shard messages are prioritized for the next block. I think there's even a guarantee, but I'm not sure about that one. But they're definitely prioritized over normal transactions. So you can take that into account when trying to perform cross-shard arbitrage with this model in place. So yeah, by all means, do check it out and give it a whirl and let me know what you think. Yeah, and that was it, I think. Yeah, Q&A. Any questions?
Is it important to like deploy on all the shards? If I am
Not necessary, no.
I can just deploy on one shard and use it for all the time, right?
Yes, yeah, you can do that. Yeah.
So do you guys have a? Sorry, go ahead.
Yeah, but I think deploying on one shard, you have no guarantee that all your users, all their accounts will live only on that shard. So some users will be performing cross-shard transactions to interact with your dApp that's only deployed on a single shard. So like with this NFT example, it's like I find it very silly and simple, and just deploys the same thing on all shards and then just like checks what shard an account belongs to. But that way you're at least dealing with every scenario in which like whatever user account where it comes from, it's at least interacting with the account with the app in its own domain. So.
So if I have an account on nil, so is it like on every shard I have different account?
No, when you have an account on nil, you have an account on one shard. So like with the, yeah, as we could see here, it makes like an account on one shard, and this one belongs to shard one.
And then it can interact with any shard?
It can interact with any shard, but it'll be doing that with async calls, with the cross-shard messages, which are handled differently, with more priority, but are also more expensive in terms of gas. And we'll have to wait until the next block for execution, because you have atomic execution within the same shard, but cross-shard is async. Yeah.
So that means, as a user, do I have to like have an account on multiple shards to like be best?
If you, like, say I were to run an arbitrage bot, I would. I'd have an account on every shard. And so I can have atomicity in every shard.
And I will have different balance on.
Yes. Yeah. My first thought would say, yeah. Yeah. Yep.
So two questions. First of all, is there a feature, like a native support feature, where if you deploy one contract to one shard, like the global consensus, or you guys can take care of deploying on the other contract as well, or other shards as well? And number two, second question would be like, if I deploy a token, for example, smart contract, the token addresses will also be different per shard.
Tokens, that's another topic. Okay, so on the first one, there's no utility yet to help you deploy on all shards. Something we can easily bake into, yeah, the library. And the CLI, there's also a CLI. And two, how do tokens work on nil? They're data that's stored in the account level. So I don't know if you're familiar with Sui. Yeah, like they carry, the tokens are objects carried by account. Very similar to that.
So that happens on the global.
Yes. Yeah. Well, every account has like just that. The data is in there, in the contract for that. Yes, it is interesting. Yes, but on the protocol level, there will be hooks for token transfers. So if a token gets sent from account A from Alice to Bob, then these hooks are called to perform some checks on the. But these hooks are also customized by the token owner, so the whoever deploys the token. Yeah. Yes.
So two questions. First, if settlement happens on L1 for cross-shard messaging, should I wait for L1 finality? And second question, which CK precompiles are available on NIL?
Question one, do you have to wait on finality? I think that depends on the consensus model, which isn't really completely finalized yet for the shards. But that also doesn't offer it depends what level of what percentage confidence do you want on that finality. But I'd wait until the CK proofs. I think that's full finality once the proof is posted and verified on L1. Or at least posted on L1. And question two, as far as I know, the precompiles are all the same. So everything EVM has, this one has too, and yeah.
There is no other precompiles?
No, there's no like Groth 16 precompile. I get that question a lot. No. Yeah. Thank you. Thanks.